Hello student, myself Nimesh Prabhakar. Welcome to Process, Dynamic and Control lecture series. In my last lecture, I discussed about the wastewater treatment plant. That means we learned in that lecture how the wastewater treatment plant works. Total operation is divided into the 10 steps and all those steps are very important. Now in this lecture we start new one chapter, that means chapter number 7, unit operation in different industry. So in this lecture mainly we discuss about the system identification. So we know what is system identification, why we require system identification, what are the use of system identification. So we discuss all this in this lecture. So we start with the system identification. So first one question come in our mind, what is system identification? So the answer is the field of system identification use a statistical method to build the mathematical models of dynamical system for measuring data. So the definition is what? The field of system identification is use the statistical method to build the mathematical model of dynamical system from measured data. System identification also include the optimal design of experiment for efficiently generating informative data for fitting such as models as well as model reduction. Then we also understand about the system identification, like a common approach is to start from the measurement of behavior of system and external influence like input to the system and try to determine a mathematical relation between them without going into many details of what is actually happening inside the system. This approach is called system identification. So this is the simple and short definition. You can understand. That means here this is the in the figure you can understand. This is the simple diagram of any system. That means in the system we give input one side and we get output. But here we cannot constantly get output, or we can say the desired value is constantly we cannot get due to the disturbance that is occur. So here the common approach is to start from the measurement of behavior of system, that means how it behave, and the external influences, that means input to the system, and try to determine a mathematical relationship between them without going into many details of what is actually happening inside the system. This approach is called system identification. Now we understand the system identification steps. So here this is the flow chart, or we can say these are the steps used to identify the system. So we understand one by one and the important step of this system identification. So first one is the experiment design. Its purpose is to obtain good experimental data, and it includes the choice of the measure variable and of the character of the input signal. Now second one step is selection of model structure. This is the most important step. So this is the selection of model structure. A suitable model structure is chosen using a prior knowledge and trial and error basis. Now third one step is the choice of criterion to fit. So which is that a suitable cost function is chosen which reflect how well the model fit the experimental data. Now next one is parameter estimation. So in this step an optimization problem is solved to obtain the numerical values of the model parameter. And next one is model validation. So this is the last one step. This model is valid or not is very much important. So the model is tested in the order to reveal any inadequacies. So these are the steps that are followed in the system identification. Now we discuss about the control method. So system identification method. So first one method is the theoretical method. So this model is theoretical model. So this model is known as white box model and first principle model. We know the theoretical model, another name is known as the white box model, or is also known as the first principle model. This model is based on the principle of conservation law. Like basic principle is used, like conservation law, like mass conservation, then energy conservation, momentum conservation, or we can say also Newton's law is used to define this model. The model are derived from the physics and chemistry of the process. Now we discuss about the advantages of this theoretical model, or we can say as a white box model. So it is applicable for wide range of conditions. So this is the most important advantage. That means we can apply this model to the all or the mostly wide range of application. It provides a physical insight into process behavior. Now we discuss about the disadvantages of this theoretical model. So first one disadvantage is it is time consuming to develop because it requires a lots of calculation. So this model is very time consuming. Then next one is some model parameters are not readily available. So this is the limitation of this model. That means there are a few parameters that are not readily available. So this is the limitation. Then like we can understand the reaction rate coefficient, overall heat transfer coefficient, or the coefficient, these are not readily available. So these are the advantages and disadvantages of this, that means theoretical model. Now we discuss about the second one model, that is empirical model. This model also known as black box model. This model is obtained by fitting experimental data. That means now we understand by using this figure. That means we have experimental setup, and in this experimental setup we give some input and we get some output. So for the different value of the input we have different value of the output. That means by using experimental setup we get the input and output data, and we can define the relation between this input and output. If we have the experimental setup and we have different sets of inputs and output data, so by fitting those experimental data, we can determine the coefficient. By that way, we can construct a model, and that model is known as empirical model. Now we discuss about the advantages of this model. So first one advantage is it is easy to develop and usually quite simple. That means as compared to theoretical model or white box model, this is easy to develop and usually quite simple. Now we discuss about the disadvantage of this model. So first one is it requires well designed and accurate experimental data. That means here we require well designed and accurate data. Then second one, the behavior predicted by empirical model is correct only around the experimental condition. This is the main limitation. Understand, the behavior predicted by the empirical model is correct only around the experimental condition. So the extrapolation is usually invalid. So this is, and third one disadvantage is it is applicable for a limited range of conditions. That means we know the advantage of white box model. That model is applicable in the wide range of application, but this model is applicable only for few limited range of conditions. So this is the advantages and disadvantages of empirical model. Now we discuss about the third one type. This is the semi-empirical model. After reading this name, you can understand semi-empirical. That means this is a combination of the white box model and black box model. That means theoretical model and empirical model. This model is also known as grey box model. This model is combined approach of theoretical as well as empirical model. That means we know that how we get grey color. By mixing the white and black, we get grey color. That's why this name is given as the grey box model. Model equations are derived from the basic conservation laws and certain model parameters. Reaction rate and heat transfer coefficient equivalent from physical experiment or from process operating data. So this is the semi-empirical model. So in this lecture we discussed about the unit operation in different industry, and that we discussed the system identification. So first we understand what is system identification and what are the steps of the system identification, and we discussed about the different models that used in the system identification. Thank you.